What is a function generator and how does it work? Imagine you're testing a new electronic device or designing a circuit. You need a way to send different signals into it to see how it responds. That's where a function generator comes in. It's a handy tool used by electrical engineers to create various electrical waveforms. These waveforms include sine waves, square waves, triangular waves, and sawtooth waves. They serve as input signals for testing, troubleshooting, and designing electronic circuits. In the world of prototyping and testing, a function generator is essential. It provides controlled, repeatable signals that mimic real-world conditions. This helps engineers see how a circuit reacts to different inputs. For example, if you are testing an amplifier, you can send a sine wave and measure the output for distortion or gain. It's a way to verify that your design works as intended before moving to the next stage. How it works starts with waveform generation. Inside the device, there is an oscillator circuit that creates a basic waveform, usually a sine wave. From this, other waveforms like square or triangular waves are made using additional circuitry. These circuits shape or modify the base signal to produce the desired waveform. Next, the frequency control adjusts how fast the waveform repeats. You can set it from very low frequencies, below 1 Hz, to several megahertz. This is done by changing the timing components in the oscillator. It's like turning a dial to get the perfect speed for your test. Amplitude control is another key feature. It changes the voltage level of the waveform, making the signal stronger or weaker. This is useful because different circuits need different input levels. For example, some sensors or components work best with low voltage signals, while others need higher levels. Waveform selection is usually done with a switch or a digital interface. You choose whether you want a sine wave, square wave, or triangle wave. Some function generators also let you add a DC offset, which shifts the entire waveform up or down. This is helpful when testing circuits that requiring a bias voltage. Finally, the generated waveform is sent out through the output terminal. You connect this to the device or circuit you are testing. The output can be monitored on an oscilloscope, which shows the shape and behavior of the signal in real time. In practical terms, a function generator helps with many tasks. It tests amplifiers by applying known signals and checking for distortion. It simulates sensor signals in control systems to see how they respond. It injects signals into communication circuits to test modulation. And it provides clock signals for digital circuits during the design process. Overall, a function generator is a core tool in electrical engineering. It allows you to create precise test signals, helping you develop better, more reliable electronic devices. Whether you are prototyping a new circuit or troubleshooting an existing one, understanding how a function generator works is a practical skill that makes testing faster and more accurate.